Okay, so we'll try and solve both of these, the system of two equations, two different ways. And remember, the third way is by graphing. So we could graph them both and solve it that way too. With graphing, and the hardest part is making sure your line is really straight, because when you graph two lines and your line's not perfectly straight, it's really hard to see the solution. And sometimes if the solution is a fraction, it's really hard to see what the answer is. So graphing works great when the answer is actually integers. But when the answer gets to fractions, that's where using the elimination or substitution method is better. Okay, so for the elimination method, the first thing that you do is let's do substitution. Substitution method, the first thing that you do is solve one equation for a variable and then plug that into the other equation. Substitution. Okay, and on a problem like this, I would probably pick this equation and I would solve for y. That's the easiest, the least amount of work. You could solve for any variable you want. If you want to solve for y in this one, that's just fine. You'll get the same answer. But I always try and find the easiest process. And for me, the easiest process here is to solve for y. So I get y equals negative 3x. There's not a negative there. Plus 16. Everybody agree with that? I just moved the 3x over. Okay. And now I'm going to plug this in, substitute it for the y in the second. Do not substitute it in for the y in the first, because then you just get, yeah, that's true, 0 equals 0. If I substitute this in here, I get 0 equals 0, and then you're going to think it's the same line. Once you solve for one equation, substitute it into the other. Okay? So I have 2x minus 3 times negative 3x plus 16 equals negative 4. Now I'm just going to distribute the negative 3 in. Negative 3 times negative 3 is 9. Negative 3 times 16, negative 48. And then solve. If I add 48, I get 44. Right? Now I'm just going to plug that in for x, and I can use either equation. I could even use this equation. Okay, so plugging 4 in, 3x, 3 times 4 plus y equals 16. 16, this is 12 minus 12. 16 minus 12 is 4. Okay, now what I can do, now that I know 4 and 4 are my answer, what I think are my answer, is I can just plug it back in here and just make sure it works in the other equation, just as a double check. 2 times 4 is 8. 3 times 4 is 12. And that does, in fact, equal negative 4. Okay? If you check your answer, you'll find mistakes if you made any. And that's a good strategy to do. Okay, let's try it with elimination now. And this is just y. Okay, with elimination, instead of solving an equation for one variable, I'm going to try and eliminate one variable. So in order to do that, I need to get one of these variables to go away when I add them. Okay? I can choose to do something to this equation and something to this one so my x's go away. Or I can choose to do something to this equation and this one and have my y's go away. For me, my strategy is always, if I ever have a coefficient of 1 in front of a variable, like this one with y, that's usually what I'm going to try and do. Because all I have to do is multiply that equation by a number. I don't have to multiply both. Okay, that's an easier strategy. Plus, the fact that I've got a plus and minus are nice too, because I don't have to multiply by a negative. I can just multiply straight across by what number? What number? 3. Because when I multiply 3 times y, I get positive 3y. Then I know when I add to negative 3y, my y's are going to eliminate or disappear. Okay, so I'm going to go ahead and multiply through, and I'm just going to write it below. And I get that. As long as I multiply that number by every term, it's still the same line. So I haven't changed anything. Okay. Now I'm just going to add these two up. 11x, that's 0, equals 44. X is 4. Then I'm just going to plug this back into one of my two originals, which I did already with the substitution method, but I'll do it again. 2 times 4 minus 3y equals negative 4. 8 minus 3y equals negative 4. Subtract 8. Negative 3y equals negative 12. Divide by negative 3. And y equals 4. Okay. I could go ahead and take x and y and put it back into this one and make sure it works. 3 times 4 is 12, plus 4 is 16. So my solution there is 4, 4. And try another one? Sure. Okay. Let's do negative 2x plus 3y equals 29. Okay, I want both substitution and elimination. So do substitution first, and now try it after that with elimination.